Okay, so if I look at this xy, then if this was a possibility, what I want to do is figure out who could that have come from. So I'm only going to do it, because we've already worked this question out, I'm only going to do it for the one answer here. But well, actually, maybe I'll show you really quickly. In this instance, it's going to be dy by dx equals 2x plus 1. It's not that one there. If I do the one I had up here, it's implicit, so it's going to be 4x minus 2y dy dx equals 0. Now I'll solve it for dy dx. So dy dx equals 4 will come over, negative 4x, and divide by negative 2y. So this will be 2x over y. Okay? Which is approximately the relationship that we had. None of them will, up here, will match up to that relationship the same way. The circle, it won't match up. It won't have the same equation because it won't produce that slope field. Okay, that's a little bit further reaching. Another thing, though, that I was mentioning, there is a shortcut here. You may not recognize this because this is no longer a part of our Math 12 curriculum, but it's definitely worthwhile to know about them. This is actually what the graph would have looked like, or closer to it. This is what we call a hyperbola. Now, or it could have been the vertical pair, right? One up and one down. So a hyperbola is different from the parabolas. It's still a conic section. So if there was something that I would say it definitely will make life easier, it will definitely make time quicker to answer questions, it's to remember that you should be able to recognize circles when they're things like, you know, x squared plus y squared is r squared. Okay? Just knowing that is going to help save time, so it's worth it. It's common enough, you see it enough, you should remember these formulas. The parabolas, I'm not even going to put up there because you know parabolas, we've done them forever in our curriculum. But ellipses, if you have an ellipse or an oval, what you have to do is you have to warp. You have to change it. So basically what you're going to find is you're going to have some number in front, like this. Something like that warps the circle into an ellipse. Okay? And I'm not going to be too specific about it. You just want to remember the sort of general characteristics. And finally, if you look at the relationship, we're adding the squares up. When we have a hyperbola, what we're going to do is subtract the squares. So it could be something like x squared minus y squared. Or it could be y squared minus x squared. Whoops, that's not an x. Okay, so the hyperbolas, they look like this. They either go a vertical pair or a horizontal pair. It's usually drawn in a pair. Okay, but they are, you know, these are I would say these are the least common of the conic sections that you'll encounter, but it's handy because, as I said, if you do run into it, you'd recognize it right away. You'd go, okay, who has the pattern x squared minus y squared? You look at your choices. Oh, there, that one has the pattern x squared minus y squared, and you can get it a lot quicker. Okay? Yes, question?
The pattern is x squared minus y squared, right?
Those produce hyperbolas, yes. If it's x squared minus y squared produces one set, like possibly vertical. Y squared minus x squared, it's the other pattern. But anyways, as I said, I don't think the specifics are as important to you that you just recognize the figure. I would be shocked if there was a specific question that had you manipulate a hyperbola in great details. I think the only time you'll see it is as we've done it up here, which is just to recognize the form that this is making a hyperbola in the slope field. Okay? So it's a time saver. It's definitely a good one. Okay, so 24 has the graph of the absolute value function. So here's what we're looking at 24. If you do absolute value of x, you get this. It's a regular line there, and because this can't be negative, it flips back up over the x-axis. So let's just say in the picture we go from -3 to +3, and it wants us to compare the left point, midpoint, trapezoid, and right point rules. So what we're looking for are these things here. Left with 2 points, the midpoint with 2, the trapezoid with 3, midpoint with 4, and the right with 6. So what this first one means is if I use 2 intervals, okay, so let's make 2 intervals. If I go from here to here, and I use the left point rule, here are my left points. There and there. Here's my intervals. 1, 2. Okay? So left point rule with 2 points looks like this. It says, will this produce the right amount of area? If I use the left point, here's the block or the rectangle that it will produce. Okay? Which looks like it's totally off. But the second time I use the left point, I get 0. There's no area added. So this figure up here, which is extra, is replaced by what's missing. So yes, it will work. Okay? So now we'll take a look at the midpoint rule. So we said that one worked. Let's do the midpoints now. Okay? Here's the midpoint of those 2 intervals. Okay? So here's the area that I've got. And here's the midpoint, which will have this figure here. So here's the rectangles in green. It's this one and this one. But again, what you should see is the part that's missing is extra. The part that's missing is extra. Okay? So that means it's still going to work for the midpoint rule. Okay, so the next one says, let's do 3 intervals. So let's try 3 intervals. And we'll use the trapezoid rule. Okay, so this time I need 3 intervals. It's going to roughly look like this. Okay, so there's going to be 1 interval there, another one, and then the last one. 1, 2, 3. So the trapezoid rule uses 2 points, this point, the next point, and it makes a trapezoid. Okay, so there's the area there. The next point is going to use this one, plus the next point, and this is the area. It's going to use this one, plus this one, and there is the area. So you can see the entire figure is covered, but there's extra now, so it will not produce the correct result. So the answer is C. Now, another thing you should notice is the graph plays on symmetry. This is a symmetric graph. These are an even number. When you break it up into even numbers, like 4, 6, 2, you don't run into problems, but you start running into problems because that's an odd number. So that might give you a clue as what to test first choice when you look at that exam.